In this example, I'm going to determine values for a and b such that this linear system is going to have an infinite number of solutions. Well, if a system has an infinite number of solutions, it's because the lines are coincident, or they are the same lines. So it looks like my first equation is in standard form, and my second equation is in point-slope form. And the b value right here is going to be the slope. So if I take the first equation and I solve for y and put it in slope-intercept form, or y equals mx plus b, I can look at that m value, know that's the slope, and then realize that both of these lines have the same slope. So let's go ahead and start and see what that looks like. So 2x minus 3y equals a. In order to solve for y, the first thing I'm going to do is subtract 2x from both sides. So I have negative 3y equals negative 2x plus a. So when I divide every single term by negative 3, I'll have y equals 2/3 x, and it looks like this weird thing right here, minus a over 3. I don't particularly care at the moment what this is going to be. The big thing is I'm just trying to pull the slope out of here. So I know the slope is going to be 2/3. So the second equation, which is in point slope form, this b value that's missing, that's actually the slope. So we know from the original problem, if this system has an infinite number of solutions, then the slopes are going to be the same. So I know that b is going to equal 2/3. Okay? So if that's the case now, my second equation looks like y minus 1 equals 2/3 x plus 6. So I could take this second equation and I could put this in y equals mx plus b form as well. So I'm going to distribute that 2/3 and then add 1 to both sides. When I do that, y equals 2/3 x. The 2/3 times the 6 is going to be plus 4 and then plus 1. So y equals 2/3 x plus 5. So looking back over here, I have y equals 2/3 x minus a over 3. I know that these two equations are ultimately identical to one another, since the original system had an infinite number of solutions, which meant the lines were coincident, or if they were the same lines. Which means I can take this piece, this positive 5, and set it equal to negative a over 3. So I can multiply both sides by negative 3. The negatives cancel on the right side, and the 3's cancel. A is by itself, and my left side is negative 15. So, from the original problem, we were looking for values of a and b such that this system had an infinite number of solutions, of course meaning that these two lines are the same exact lines. I went ahead and put the first equation in slope-intercept form, and I found the slope. So I knew that my value of b, that was my slope. So once I knew what b was, I could take this equation, which was in point-slope form, put it in slope-intercept form, set these two things equal to each other, and then go ahead and solve for a. Okay, so that's a matter of taking information that you know and applying it to a linear system and finding information that you would like to know, values for a and b.